Back. This is Mr. Hassan's Maths channel, and I'm now answering some questions from this new syllabus of Edexcel International Exams for IGCSE. So they have the new modular exam where you can take papers at different sessions if you want to. Like you take, Unit 1 in September, Unit 2 in January, and so on. You can retake units within a certain time frame and improve your marks, and so on and so forth. So this is going to be This is a new series which will be first examined in June 2025. Okay, so the first paper will be held in June 2025 for the Unit 1 higher paper. That's what I'm going to go through. I'm going through the higher tier, and so I'm going to go through these questions. And I'm going to go through them one by one, okay? And I'm going to save each video separately such that I can save the videos in terms of topic as well as in terms of paper. And so I'll build up an index of topics as well as papers. And I will try to go through each question in such a way that a student who hasn't had any previous kind of exposure to these topics should be able to understand. I'm not just going to do like a walkthrough where I just answer the questions as if I'm taking the exam myself. I'm going to take some time to explain the concepts and try to think of those kind of issues where I find that students have had, misconceptions or make common mistakes, and the type of questions that students maybe they find a bit difficult. I will try to explain in a clear way such that this becomes a teaching tool. So I'm going to go straight into the paper. So these papers are 2-hour papers. This is the 2-hour paper. You're allowed to use a calculator, okay? And basically the instructions are here, okay? And you must show your steps and your working, answer in the space required, and as we said, the total marks for this unit is 100, and it doesn't mention here about rounding. Does it mention about rounding? It doesn't mention about rounding. Sometimes it should do. No? Okay, normally it would say for values which are, or for answers which are not exact, then you should give your answers to 3 significant figures. It normally says that in the beginning. It doesn't say it this time, but that's generally the standard, unless otherwise stated. Anyway, let's see how it unfolds. Now, you get this formula sheet, okay, for this paper, which includes certain types of formula, like the sum to n series of arithmetic series. It doesn't tell you how to find the nth term, but it gives you the sum to n series. You've got the quadratic formula. They give you the area of a trapezium. They give you the sine rule, the cosine rule, the area of a triangle, volume of cones, volume of prism, general formula for that, volume of sphere, surface area of a sphere, volume of a cylinder, and the curved surface area of a cylinder. Those are some of the formulae that they give you in the formula sheet. Okay, and that's basically that. So now we want to start with question number 1. Okay, it says the weight of a cake is 2.7 kilograms, correct to 2 decimal places. So here we have a question about upper and lower bounds. Write down the lower bound of the weight of the cake. So we have the weight, okay, it's 2.75 kilograms, correct to 2 decimal places. We want to write down the lower bound of the weight of the cake. All right, so now, when you want to round when something's been rounded correct to a certain place value, okay, then to answer this question, what you need to do is you got to think of the second decimal place. It's in the place of the hundredths. Okay, so you have your decimal point. Let me just make this a bit smaller. You have your decimal point, you have your units, you have your tens, you have your hundreds, and here you have your tenths, and here you have your hundredths. So 2 decimal places, we're talking about this position over here. We're talking about that place over there. Okay. the hundredths. Let me write that a bit clearly. It's supposed to be 2 zeros there, hundredths. Okay, so we're thinking about the second decimal place. So that's represented by the value 0.01. So you can say it's been rounded to the nearest 0.01. The nearest 0.01. So what we do is we take what has been rounded to and we divide that by 2. So 0.01 divided by 2, you could use your calculator to work that out, but it's going to be 0.005. It's always going to be an extra 0 and then a 5. Because if you try to divide, 2 doesn't go into 0, so you have 0. 2 doesn't go to 0 again, you have 0. Then you have to add another 0, okay? So like if you try to divide this, of course you don't need to know this if you have a calculator, but it's good to have an idea of this. Let me put it a bit neater. Just to show you how this pans out every time. So you have 2 into 0.01. So 2 into 0 doesn't go, there's no remainder. 2 into 0 doesn't go, there's no remainder. 2 into 1 doesn't go, there's a remainder of 1 now. So 2 into 10 goes 5 times, no remainder, so you're left with 0.005. So always be, when you divide 0.0 something, like 1 divided by 2, it's always going to be an extra 0, then a 5 at the end. So if it was 0.001 divided by 2, you would add a third 0, so 0.0005. So add another 0 and then a 5 when you divide it by 2. That's just a little tip there. You can just put it in your calculator, but it's very easy if you just remember that. Okay, so now, so that means, okay, we take this value here and we have our 2.75, and to find the upper bound, we will add 0.005 to it. And to find the lower bound, we subtract 0.005 to it. Okay, in this case, we have to subtract because we have, to find the lower bound. The lower bound will be 0.005. Take away from 2.75. So 2.75, take away 0.005. So we can see what we're going to get is 2.745. So 2.745 is the lower bound. Okay. Now we can think about this in the following way. I'm going to try to make it kind of like clear as the reasoning behind what we did, because I don't like just to explain a procedure without giving some sort of understanding of what's behind that procedure, so you have a proper, full understanding of what's going on. So we want to round to the nearest hundredth, which is 2 decimal places. So the number itself was 2.75. The next hundredth up would be 2.76, and the next hundredth down will be 2.74. Right? So that would be the next hundredth down, and that would be the next hundredth up. 2.74, 2.76. So basically, if something rounds to the nearest hundredth, okay, to the nearest hundredth, then it has to lie somewhere in this area here to 2.75. Okay, so if it's to the nearest hundredth 2.75, then it's going to be somewhere between these two values here, 2.75. So it should be like, this is the halfway between 2.74 and 2.75. So that's 2.745. And that's halfway between 2.75 and 2.76. So that's 2.755. So the lower bound of this is 2.745 and the upper bound is 2.755. What we're after is the lower bound. So anything that is 2.745 and above, when you round it, we'll get to 2.75. So that's the lowest it can be, such that it rounds to 2.75. If it's any lower than that, it will round to 2.74, because it'll be closer to 2.74, then it's 2.75. And if it's anything up to just before 2.755, then it will round to 2.75. If it's 2.755 and above, it will round to 2.76. Okay, so this is called the upper bound. If this question was about the upper bound, then this would be the upper bound, because the upper bound means everything up to, not including that. That's the upper bound. Right? This question is asking about the lower bound, so there's not such a big problem there. But if they did say upper bound, we would write 2.755. But in this case, it's 2.745 because we're looking for the lower bound. And there's the answer to this question. Okay, so this is from the topic of upper and lower bounds, and an important topic which, tried to give some sort of background to it. Now, if you didn't understand what I explained here, and you just want to know the procedure, it's a very simple procedure. It says nearest 2 decimal places. So you write 0.01 to 2 decimal places, always a 1 here. Divide that by 2, that gives you 0.05. 0.005, sorry, 1 extra 0, then a 5. And then to find the lower bound, you take the original number and you subtract. You subtract this. Okay, so 2.75 minus 0.005, and that gives you 2.745. And there is the answer to question number 1. Okay, so as I said, I'm going to answer each question on a separate video so that I can explain things according to topics and save them according to topics as well as papers. So if you'd like to see the other questions from this particular paper, you can click on the link over here and it will take you to the playlist for the paper. If you click on the link over here, it will take you to the playlist for my Unit 1 questions on lower and upper bounds. Okay, and I will also have a link here for the other questions that you'll find about lower and upper bounds from other exam boards as well. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.